This is Lesson 1, How a Turbine Works. In this and following lessons, you will learn about the basic principles which make the turbine engine a highly reliable power producer. Understanding how the engine works in the most basic terms will allow you to build your knowledge of these complex processes more quickly and thoroughly. This lesson addresses these processes at a fundamental level and provides the foundation for the remainder of the course. When you finish this lesson, demonstrate your understanding by taking the progress check on the following performance objectives. 1. List the 4 processes of engine operation. 2. Identify the location of energy conversion into useful power. 3. Name the 2 ways expanded gas is used by the turbine rotor. Your instructor is Don Lovejoy.
The industrial turbine engine is an internal combustion engine which produces horsepower by using the energy of highly compressed air mixed with fuel and ignited under special conditions. It is in the ignition and combustion process that heat energy is produced, which is converted into power useful for work. Continuous operation of the engine requires that 4 processes occur. Compression, atmospheric air is compressed. Combustion, fuel is added to the compressed air and ignited. Expansion, air and combustion gases expand through nozzles. Exhaust, air and combustion gases are discharged into the atmosphere. To begin the process of energy production, air is first drawn into the compressor, where rows of blades compress the air into an increasingly smaller space. Energy to turn the compressor is first supplied from the external start system until the turbine has enough power to turn the compressor over by itself. After the air leaves the compressor, it enters the diffuser area. In the diffuser, an additional pressure rise occurs. The pressure at the exit of the diffuser is about 118 pounds per square inch at operational speed and full load, right about here. After the air leaves the diffuser, it enters the combustion chamber, where either liquid or gas fuel is added to the air. This highly pressurized air and fuel mixture is then ignited by a fuel-fed torch. The combustion process releases the energy of the fuel in a temperature rise in the combustor, and after ignition has taken place, the hot gas expands very rapidly so that its velocity and its volume increases. The average temperature in the combustion chamber is about 1600 degrees Fahrenheit. These hot gases expand through the turbine section, deflect the turbine rotor blades, and turn the turbine rotor. The turbine rotor then produces the power to turn the compressor and produces the power to turn the electrical generator. As the expanding gases flow through the turbine section, their temperature and pressure drops, and they ultimately exit the turbine into the atmosphere through the exhaust diffuser.
Now that you've seen the basics of how a turbine engine works, review what you've learned. The 4 processes which permit the engine to operate are compression, combustion, expansion, exhaust. Energy is converted to useful power at the turbine rotor. The turbine rotor provides power to drive the compressor for sustained operation, the generator for electrical production. You have seen how compressed air and fuel are combusted and how this rapidly expanding hot gas is used to turn the turbine rotor. Smooth operation is achieved by transferring some of this power into further compression of air. The turbine engine is a heat engine. converting heat energy into power. Each of the four processes contribute to the uniform performance of the engine and will be examined in more detail in the remaining lessons of this module.